Namaskar, hello and welcome to CIET NCERT's live phone-in interactive program. My name is Tanvi Khurana and in this maths class for all the 6th class students, you can join us in this session through various mediums. You're watching us live on PMeVIDYA channel number 6 and the topic we are going to discuss is whole numbers, and this is the first part because whole numbers is a huge topic. So we'll ask ma'am what are whole numbers and she'll also give us certain examples. She'll solve certain questions of whole numbers. But if you have any questions, any queries, please feel free and give us a call on our number 8800440559. You're watching us on our YouTube channel, which is NCERT Official. In the live chat box also, you can write down all the equations which you are unable to solve and share them with us. Maybe ma'am can help you with those equations. So this is one of the mediums, and also you can email us on our email ID, which is dth.class6@ciet.nic.in. Let me introduce our today's expert with all of you. She is Miss Swarnlata Sharma. Welcome, ma'am.
Thank you, Tanvi. Thank you.
Thank you, ma'am, for being with us. I'll just introduce you to our viewers and then we'll begin this discussion. So, ma'am is a TGT in mathematics from Dr. Rajendra Prasad Kendriya Vidyalaya, President's Estate, New Delhi. So, let's begin, and I would like to ask ma'am, what exactly are whole numbers? Can you just define it for our viewers and also let us know what are natural numbers because they are in sync with each other?
Yes, Tanvi. We will discuss today about whole numbers. But before going to whole numbers, let us first revise what are natural numbers. As we know, we use numbers like 1, 2, 3, 4, 5, etc. when we begin to count. They come naturally when we start counting, isn't it? Hence, mathematicians call the counting numbers as natural numbers. That means the numbers which we use for counting are known as natural numbers. Now, if we add 0 to this, we get another set of numbers known as numbers. So, are 0, 1, 2, 3, 4, 5 and so on. Next slide, please. Yeah. The natural numbers along with 0 form the collection of whole numbers, as I told you, 0, 1, 2, 3, 4, 5 and so on. Next slide. Yeah, we have seen that the number 1 has no predecessor in natural numbers. To the collection of natural numbers, we add 0 as the predecessor for 1. That means the natural numbers along with 0 form the collection of whole numbers. Right? Next slide. Now let us look into some interesting questions. Are all natural numbers also whole numbers? Yes. All natural numbers are also whole numbers. Are all whole numbers also natural numbers? No, as 0 is not a natural number. We know the natural number begin with 1, whereas whole numbers begin with 0. Next question, which is the smallest natural number? Obviously 1. 1 is the smallest natural number. Now another question, which is the smallest whole number then? 0. 0 is the smallest whole number. Right, Tanvi? We have seen that. Yeah. 0 is the smallest whole number and 1 is the smallest natural number. Now, we have a question here. Which of the following statements are true and which are false? First one, 400 is the predecessor of 399. This is false because predecessor means I should subtract 1 from 399. So here predecessor will be 398. Therefore, 400 is a wrong answer. 400 is not the predecessor of 399. It is false. Next statement is 600 is the successor of 599. This is true because successor we get on adding 1 to the number. That is 599 plus 1 is equal to 600. Next statement is the predecessor of a two-digit number is never a single-digit number. This is false because I have an example here. Predecessor of two-digit number. Two-digit number, let us take 10.
10.
Okay?
Yeah.
10 is a two-digit number. If I subtract like 1, I get 9. 9 is a single-digit number. So, there is a single-digit number which is a predecessor of a two-digit number. So, therefore, the statement is false. Okay? Next statement is 1 is the smallest whole number. This is obviously false. Just now we discussed that 0 is the smallest whole number.
Yes.
Next, the natural number 1 has no predecessor. This is true, right? Because natural numbers begin with 1.
Yeah.
Therefore, they have no predecessors. The whole number 1 has no predecessor. This is false because 0 is the predecessor of 1. Next statement is the whole number 13 lies between 11 and 12. This is false because 13 does not lie between 11 and 12. Am I right? Yes.
Yes, ma'am.
And yes, the whole number 0 has no predecessor. This is true. And the successor of a two-digit number is always a two-digit number. This is false. Can you tell me why? Because suppose I take two-digit number 99. If I add 1 to that, what 99 plus 1? It is 100. And 100 is not a two-digit number, it is a three-digit number. Therefore, this statement is false. Okay?
Okay.
Next. Now, let us just revisit again what is predecessor and successor. We had learned in the previous chapter, children. We had studied about knowing our numbers. In that, we came across predecessor and successor. Given any natural number, you can add 1 to that number and get the next number. That is, you get its successor. The successor of 16 is 16 plus 1, that is equal to 17. That of 19 is 19 plus 1 is equal to 20. What about predecessor? The number 16 comes before 17. So we say that the predecessor of 17 is 17 minus 1, that is equal to 16. And the predecessor of 20 is 20 minus 1, that is equal to 19. I think the concept is clear.
Yes, ma'am. Very much clear.
Now, let us, today we will discuss about the properties of whole numbers, Tanvi. They are very, very useful. See, when we look into various operations on numbers, clearly we notice several properties of whole numbers. These properties help us to understand the numbers better. Moreover, they make calculations under certain operations very simple. Let us look into what are these. Next slide. Properties of whole numbers. Today we will discuss about addition. Okay. So addition of whole number possesses the following properties. First one, closure property. Excuse me.
So first is the closure property, as you all can see on your screens. So I'll request ma'am to continue and let us know about these properties of whole numbers. So ma'am.
Yes. Addition of whole numbers, they possess the following properties. First one is closure property. If A and B are two whole numbers, then A plus B is also a whole number. In other words, sum of any two whole numbers is a whole number, or whole numbers are closed for addition. Example, 2 plus 3 is equal to 5, or 4 plus 5 is equal to 9. Suppose I take 2 plus 3. I am getting 5. Here 2 is also a whole number, 3 is also a whole number,
Yes.
and 5 is also a whole number. Okay. Likewise, 1 plus 4 is 5. 1 is also a whole number, 4 is also a whole number, and 5 is also a whole number. Alright, this is known as closure property.
Okay.
Now let us come to commutativity. If A and B are any two whole numbers, then A plus B is equal to B plus A. In other words, the sum of two whole numbers remains the same, even if the order of whole numbers is changed. That means it does not matter if I add 2 to 7 or 7 to 2. That means 2 plus 7 is also 9 and 7 plus 2 also is 9. Right?
Right. And should I read out the last example, ma'am?
Yes, please.
Okay. So here you can see, just like 7 plus 2, 4 plus 3 is 7. And similarly, we can write 3 plus 4 and the result will also be 7. So we can interchange the words, the numbers, and the result would be the same. Am I right, ma'am?
Yes, Beta, thank you.
Okay.
Next slide, please. Existence of additive identity. If A is any whole number, then A plus 0 is equal to A, that is equal to 0 plus A. In other words, the sum of any whole number and 0 is the number itself. That is, 0 is any whole number that does not change the value of the number it is added to. The whole number 0 is known as the additive identity. So remember children, 0 is known as the additive identity or the identity element for addition of whole numbers. Reason is, suppose I add 6 plus 0, I will again get 6. Suppose I add 77 plus 0, I will get 77. The value of the number does not change. Therefore, it is known as the additive identity. Right?
Right.
Next slide. Associativity. If A, B, C are any three whole numbers, then within brackets if I write A plus B plus C is same as writing A plus within brackets B plus C. In other words, the addition of whole numbers is associative. For example, if I take 2 plus 3 within brackets plus 5 is same as 2 plus within brackets 3 plus 5. Look children, 2 plus 3 is 5, 5 plus 5 gives me 10. Same way, 2 plus 3 plus 5, 3 plus 5 is 8, 8 plus 2 is again 10. Got it?
Right.
Like 1 plus 4 within brackets plus 3 is equal to 1 plus within brackets 4 plus 3. Each is equal to 8. Isn't it? So this is associative property. Now important note about this is, as a consequence of commutativity and associativity of addition of whole numbers, we find that to add 4 or more numbers, it is not necessary to add them in order they are given. We first group them in such a way that the calculation becomes easier and then find their sum.
Absolutely.
Okay?
Yes. Should I read the
order doesn't
important
matter.
note again, ma'am?
Yes, beta, please.
Okay, so let's have the important note once again on the screen. And as a consequence of the commutativity and associativity of addition of whole numbers, we find that to add 4 or more numbers, it is not necessary to add them in the order they are given. We first group them in such a way that the calculation becomes easier and then find their sum. Okay, let's move on.
Yes, next. Let us look into some examples here. Add the numbers 234, 197 and 103. We are seeing that 234 plus, we are writing within brackets 197 plus 103. I find that 197 plus 103 gives 300. It is easy for me to add 300 to 234. It gives me 534, right? It is easy to add if I just club these numbers in this way. In the next question we have find 14 plus 17 plus 6 in two ways. Okay, 14 plus 17 we are adding first, plus 6 gives us 31 plus 6, that is equal to 37. Next way is 14 plus 6 plus 17. Numbers are the same. We are just arranging them in such a way. What is 14 plus 6? It is 20.
Right.
20 plus 17 gives
37.
Here, yes. Here we have used a combination of associative and commutative properties for addition. Right, children?
Right, ma'am.
Next slide. Yes. Do you think using the commutativity and associative property has made the calculation easier? Do you think so?
Yes, ma'am.
Let us try this. Let us try. See here on the board, I have the first question. 837 plus 208 plus 363. Let me add these two numbers first. See, if I write 837 plus 363 plus 208. If I add these two numbers, 7 plus 3 is 10. Again 1 carry, again 10. So here I get this as 1200 plus 208. This becomes easy for me to add and I get 1408. Okay, so I can find the sum by suitable arrangements. If I add these two numbers, I get a simple number to add with the other addend. Likewise, if I have to add these four numbers, the clue here is, can we see here, 3 plus 7 gives me 10.
Yes.
And 8 plus 2 also gives me 10.
Right.
Units to see. So let me write down these numbers in such a way. See, 1962 plus 1538 plus 453 plus 647. Now, if I add these two numbers, what is 8 plus 2? 10. 1 carry, again 10. 1 carry, you get here 5. And this is 3. So, 3500 plus, if I add this, I will get 10, again 10, and this is 11. Obviously, children, if we add this, I think I will get 4600. In this way, the calculations become very easy when we use the commutative and associative property.
Right.
Right?
Because otherwise, after looking at the numbers, I think students will get scared.
Yes. This is the beauty of the property of commutativity and associativity, that they make our calculations very easy. We can add large numbers very quickly.
Okay.
Next slide, please.
Yes.
Yes. Here comes another concept, that is the number line. Draw a line. Here, see, I have done a line for you. See, this is a number line, and we mark 0 first, and then the second point is marked after a distance of, let me take it as a unit distance. That distance is going to remain the same for all different numbers. Okay, distance between these points labeled as 0 and 1 is known as unit distance. Next slide. Likewise, I go on marking with unit distance 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. So on this line, when we mark these points towards the right, I can mark as many as I want the whole numbers.
Okay.
Okay. This is known as number line for whole numbers.
Okay.
In this, see, we have a number line from 1. All these numbers are natural numbers. But if I include 0 along with natural numbers, they form whole numbers. Right?
Yes. Yes, ma'am.
Yes. Next slide, please. Yes. Now we'll just revise the concept what we have studied today. The numbers 1, 2, 3, which we use for counting, are known as natural numbers. And if you add 1 to the natural number, we get its successor. If we subtract 1 from the natural number, you get its predecessor. And every natural number has a successor. Every natural number except 1 has a predecessor. Okay. Next slide, we see if we add the number 0 to the collection of natural numbers, we get the collection of whole numbers. Thus, the numbers 0, 1, 2, 3, etc. form the collection of whole numbers. Next point is every whole number has a successor. Every whole number except 0 has a predecessor. Okay, children. Next slide. All natural numbers are whole numbers, but all whole numbers are not natural numbers. In the 7th point, we just now looked into the number line. We take a line, mark a point on it and label it as 0. We then mark out points to the right of 0 at equal intervals. Label them as 1, 2, 3 and so on. Thus, we have a number line with the whole numbers represented on it. We can easily perform the number operations of addition, subtraction and multiplication on the number line. Okay, this we will do in the next session. Addition and subtraction and multiplication of whole numbers on number line. That is very interesting.
Okay.
So I hope, Tanvi, the concept is clear today.
Yes,
Natural numbers are the numbers we use for count, and the whole numbers, when we include 0 along with natural numbers, they form our whole numbers.
Yes. The concept is crystal clear, ma'am, and as you have given the gist of what we are going to understand in the next session of the whole numbers, I'll eagerly wait for your next session, and I hope it will come very soon. And I'm sure our viewers and students, they'll also be waiting for the same session. Thank you so much, ma'am, for for explaining the entire concept of whole numbers and even natural numbers to our students so beautifully. Thank you.
Thank you. Thank you, Tanvi.
Thank you. Thank you to all the viewers for watching this session. Ma'am even solved a few equations for you to understand the concept better. If still there are any doubts, any queries, please reach out to us. You can share your questions through our YouTube channel, which is NCERT Official. In the live chat box, write down your equations, questions. Because this is a math session, your equations are more than welcome. We'll be answering them very soon, and if we won't answer it in this session, maybe we'll take it up in the whole session, whole numbers part 2. So thank you so much once again for giving us your time. Keep on watching PMeVIDYA channels, and our next session is webinar, which is going to come in a few minutes. But before that, let me give you a very important information regarding कला उत्सव, राष्ट्रीय कला उत्सव, जो कि 1 जनवरी 2022 से शुरू हुआ था और 12 जनवरी यानी कि आज आखिरी दिन है हमारे राष्ट्रीय कला उत्सव का। तो हम उम्मीद करते हैं आप इस लिंक के माध्यम से ज़रूर जुड़ेंगे और इस कार्यक्रम का पूरा आनंद लेंगे। स्कूल शिक्षा और साक्षरता विभाग द्वारा शिक्षा मंत्रालय भारत सरकार की पहल पर एनसीईआरटी के सौजन्य से 1 से 12 जनवरी 2022 तक राष्ट्रीय कला उत्सव को आयोजित किया गया है। बहुत धन्यवाद एक बार फिर से आप सभी का, और PMeVIDYA चैनल बिल्कुल देखना मत भूलिएगा। नमस्कार।